Welcome to Embedded Internals. This is second episode of our series C System Fundamental series. In this episode, we are going to see how computer represent numbers. In this episode, you are going to understand that computer do not understand decimal numbers. Computers fundamentally stores the data which is written in bits, binary patterns, or in the electrical state. So first pointer is why computer uses binary. Everything is binary format, either 0 or either 1. This is what machine understands. It does not understand the value written as 650FD or anything. This is the programmer representation form. We know that CPU deals with voltage present or voltage absent. You have seen this electrical signals either high or low, voltage present, voltage absent, present, voltage absent, high bit, low bit, on, off, true, false. It is just in representation. So at the end, it is all the electrical signals. We have everything in the terms of voltage. Electrical format, when we are talking, it is like high or low. So all the data finally needs to convert it into electrical signals only. So what it mean by bits, bytes, binary, hex, what is all these things? How we can understand and represent that? The first thing is, what is bit? When we say bit, it is the smallest unit of information in computing. Smallest unit. So bit has only two possible value, that is 0 or 1, high or low. So when we are talking in terms of bit, so bit can represent electrical signals. Smallest unit, so it can represent electrical signals or charges or transistor states or magnetic polarity, optical state, anything you can say. Here we are talking in terms of wires, electrical signals, hardware, that component terms. So when we are saying bit or binary terms 0 or 1, it is just a physical reality translated into logic. So we cannot read everything as 0 0 0 0 0, hundreds of 0 in between, someone in between. This will be very difficult to interpret, to understand, even for assembly level programmers as well. So to make it easy, we have bytes. This is how we store memory. Bytes means 8 bit. So this is 8 bit, 0 to 7. This 8 bit is called as 1 byte. We can take as example 0 1 0 0 0 1 0 1. So this is 8 bit, and this complete is 1 byte, and this 4 combination of 4 is nibble, higher and lower nibble. So why 8 bit is 8? Why only 8 bits? Why not 10, 32? What 8 bit represent? When we are saying 8 bit, it is like 2 to the power 8, that is 256. So 8 bit can represent 256 possible values, and the range will become 0 to 255. This is our complete byte range. All the memories are usually represented into bytes. When we are saying memories are bytes, so our addresses are written into 0 into 1000, 0 into 1001, 0 into 1002, like this. And the value they corresponding to any value, 1001, 0011, 0110, 00000001, any value. So addresses are just fixed index in byte format. Actually, in the number system, we have multiple number system like decimal, octal, hexadecimal, binary. All number system can be distinguished by their bases. Like decimal is base 10, octal is base 8, hexadecimal is base 16, whereas binary is base 2. For example, we have a decimal number 345. We know that decimal has a base of 10, so we will multiply it by base of 10. 2 to the power at the second value, first value, 0 value. So 0 1 2, 2 to the power 2 plus 4 value into 10 to the power 1 plus 5 value into 10 to the power 0. And this will how the number will be represented inside. Similarly, when we are saying binary place value number, binary value like 0 1 0 0, when this will be converted, so this 0 1 2 3, it will become 1 into binary base has base value 2, so 2 to the power 3 plus 0 into 2 to the power plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. So 2 to the power 0 is 1. 2 to the power is 2 is 2 into 1 is 2. 2 to the power 2 is 4. Multiply by 0. So value becomes 0. 2 to the power 3 is 8 into 1 is 8. So the value become 8 plus 2 10 plus 1 11. So this term will become 11. So this is how we calculate based on the base value of our number system. Let me give you a quick idea how to convert these values. Like any value which is written in decimal need to be converted into binary. How you can do it? So 13 is the decimal number. You need to convert that into the binary. What you will do? We have a repeated division method. Binary, we need to convert it into the binary, and we know the base of binary is 2. So we kept on dividing it by 2. 32 divided by, now 6 divided by 2, value is 3, remainder is 0. 3 divided by 2, value is 1, remainder is 1. 1 divided by 2, value is 0, remainder is 1. Now from lower to upper, read from bottom to up. The value will become 1 1 0 0. Now convert 2 to the base 0, base 1, base 2, base 3. 2 to the 8, base 3 is 8 4 0 1. That will become 13. This is how you will convert decimal number into the binary number. Similar way, we have the conversion of binary to decimal. We can do the multiplication, right? From higher base level to the lower level, higher base, like decimal has base 10. We are going to the lower base. Binary has base 2. We will do division. With the base, we need to convert. Similarly, when we have lower base level, that is binary, we need to convert that same into the decimal. Decimal has base 10. We will do multiplication. I will give you an example. Like we have one value, this 0 1. Binary value, so base of 2. We need to convert it into the decimal, so we will do the multiplication. So it will become 0 1 2 3 4 5. 2 to the power 5. 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. 32 plus 16 plus 4 plus 1. So this will become 53. So this is how you will convert decimal value into binary. Take any example and use this logic. You will get the binary to decimal conversion, and the similar way you can do other conversions as well. Decimal to hexadecimal, decimal to binary. You are using multiplication and division methodologies. Just remember, higher base to lower base, divide. Lower base to higher base, multiply. Why we need hexadecimal this? We are not able to understand everything in 0 1 0 1 0 1. How long we are going to convert it? Like, let me give you an example. 1 1 0 0 1 0 0 0 1 0 0 1 1 1 1 1 0 1. Now do the conversion. How long it will take? It becomes so difficult to understand and to deal with it. So it becomes hard to read. Now comes the term hex. which compresses the binary and make the data understandable, readable. So we know that hexadecimal has a base of 16. Base 16 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So 0 to F, that is 16 number. So mapping will similarly like 0 will be represented as 0 0 0 0, 1 as 0 0 0 1, 2 as 0 0 1 0. Similar way till the time F we have 1 1 1 1 1. So this is how the mapping is done for the hexadecimal to the binary. Now we have seen that one hexadecimal digit is 4-bit, right? 0 is 0 0 0 0. Similarly, when we can say 8, it become 1 0 0 0. Let me say D, 13. So 8 plus 4 12 plus 1 13. F, that is 15. So 1 1 1 1. So this is like one hex digit, 4 bits. Two hex digit, 8 bits. When we have to convert this 1 1 1 1 1 0 0 0, so it will become F and this will become 8. So this large value of 8-bit become F8, or we use 0 into X to represent hexadecimal format. So it will become so easily understandable. Let me show you an example. I have an variable, character variable, where I have stored A and printed the representation in the D and C form. Let me show you. 65A, where this 65 comes from? Same bit but different representation. Let me show you a sky table inside. So 65 decimal value in the hexadecimal value 41, and that is represented, that represent a number, character A. So similar way we have complete representation of every value into the hexadecimal format. This is called ASCII encoding, where every character is encoded into the ASCII format. Like A is in the hex 0 into 41, or in the decimal 65. J is in the hex 0 into 4A, in the decimal 74. Like this, every characters are number. And this is because of ASCII encoding, we are getting that ASCII value of A. 65 in the decimal format, we get the decimal value as the decimal is represented, 65 is represented by the A. So this. Okay. So this term is an ASCII encoding, where every character is encoded to corresponding to its ASCII format. Okay. Let's go back to the smallest unit, that is bits. How bits can be used as flags to map the hardware registers. Now we have a value 0 0 0 0 0 1 0 0. Okay. In the hexadecimal format, we can write as 0 into 4 plus 1 5. Okay. Where 0 means off bit and 1 represent on bit. Voltage signal high, voltage signal low. We can see these format are used everywhere. They are used for permissions. All the hardware flags are mapped as hardware, all the hardware registers are mapped in this format. They are used in networking and protocols. We will cover bits as flags in very detailed in our 7th episode. Just understand that in the hardware level, everything is represented in this format, and whether we have to declare the permission, we will give any value, and if that value is high or low, we will just compare at the bit level. Bit 5 is high, Okay, do this operation. Bit 5 is low, do this operation. So if there is a 8 bit, all the 8 bit representing some or the other things, so we are going to uh, control our registers our bit level. So this is a register R0. Go to the bit 0 of R0 and check the value. If it is high or low, do the operations. Now, what is unsigned integers? We know that 8 bits, which is equal to 8 byte, 1 byte, which is equal to 256 values. These values can be signed as well as unsigned. So the range will become 0 to 2 to the power 8 minus 1, that is 0 to 255. This will be the range. Minus 127 to plus 128. This will be the complete range from the signed and unsigned integer value. So the integers are not just signed values, they can be unsigned values as well. Okay. We will convert this in next episode. So we can say that memory is a sequential bytes and addresses are located in bytes only. CPU reads the value in bytes. All memories are represented in bytes. Memory representation bytes. Addresses are written in bytes, sequential bytes. Okay. Now let us see one program to see the binary nature of our number system. Okay. So we have one character, unsigned char, that is 255, and we have just printed what is the binary representation of this value. So it is binary view. All the program we are using in our episode will be present in our GitHub page. You can check out from there as well. So binary representation for 255 is all 1. Binary representation for 10, 1010. 2 to the power 0 is 0, 2 to the power 1 is 2, so 2 plus 2 to the power 2 is 0, so normal. 2 to the power 3 is 8, so 8 plus 2, that is 10. So this is how we can check the binary representation of any value using the /b, print b is for binary. So we have seen that 255, like 10 is just a 4-bit number, 4-bit, whereas 255 complete 8-bit. So 255 fits exactly in 8 bits. All are 1, all the signals high, so we get the 255. That is the highest range of 1 byte. Okay. Where hex is actually used. All the memories are mapped into this hex format, binary format, hexadecimal format as only. So mostly in the real system, data are represented, memory addresses are represented in the hexadecimal format only. Okay. Similarly, if you can see the debuggers, packet analyzers, they all are into the hexadecimal format only. Wireshark, we can see hex codes. So in the real system, all the memory addresses, packets, in the Wireshark we can track that. Machine codes are represented into the hexadecimal format. Hexadecimal base of 16, 0 to F. 1 bit, 1 value, 4 bit only. Assembly format. I will show you the assembly as well. So addresses are in hexadecimal format only, right? So like we have this value, so this will be 0 and this will be 7. So 6, 5, 4, 3, 2, 1. So only 2 bits are high. That is 2 to the power 0 bit is high and 2 to the power 6 bit is high. Okay. 2 to the power 6 is 64 and 2 to the power 1 is 1. In the ASCII term, we have seen decimal value 65 is being represented by the word A, character A. And when we are talking in the hex term, it will become 0 into 4 1, right? 4 bits to 1, and this is 4. So same binary is represented into decimal, character, hexadecimal. They can become the part of float, machine instruction, or can represent any value. So depending upon our interpretation, number exists, right? And this is the idea of computing, that we are talking in the terms of bits, patterns, and interpretations. We can give that 0 into 4, okay, or represent this value into as a number read. So this is our representation. We are representing our bits. Okay, I hope this is clear. So we can say that at the hardware, when we are talking at the hardware perspective, images, videos, numbers, characters, programs, even our operating system, all are bits. Now in this episode, we understand what is bytes, what is nibble, what are hex, what is decimals, how memories are represented inside system, how programs are represented inside system. In the next episode, we are going to understand what C type actually mean in memory. Stay tuned for same. Thank you.